they?
What's
Okay. Spider ring.
Okay.
Yeah.
Here, what if I just like?
That's
Y'all ain't
cool.
ready for this.
Hold on. Let me get some more.
Wait, do you have more? Here, back.
Catch a packet. Fuck.
And the chain.
And the chain.
Chain.
Chain will look cool.
I've got chain and catch a packet.
Nice. So I need
Nice.
like
What am I supposed
essentials.
to? I know. It's like, what are
Right?
you supposed to do with that?
Wear your ring on a chain.
Like around your neck, like a little spider or something. I saw this TikTok of this girl who was wearing like a spider earring, and it was like a really big spider earring.
Oh my
But
God.
she forgot that she was wearing spider earrings, so when she looked at her screen, she thought there was like a spider
Oh my
crawling
God.
across her face. And
Why is that though? I'd be like, whoa.
I'd be like,
what is
that. I'd be like, that would be you.
Yeah. You got it. I don't know where the other ones went. I had a whole bunch. Maybe I kept giving them out. That's my problem.
Yeah.
I'm too generous. Alright, I got hand sanitizer sponsored by Jane Health Center.
Very nice.
Probably where we all have COVID now.
Catch a packet sponsored by Airmark.
Oh God, Aaron. Fuck Aaron. Stupid. I know we're like number 8 for food because of them, but there's us.
There's.
They use prison labor. That's not cool. Fuck, this is squeaky.
Thank you. Oh no. Oh no. Okay, we're because they're not for us.
Oh my God. I'll take my wares and go elsewhere.
My
Traveling so crazy.
We're gonna be witches. Get your ring.
Oh shit, let's see. The colt.
The cult. You got Alex and Laura. Which cult?
You know what this class is missing?
Huh?
This class is missing an Among Us server.
Oh shit! No, wait, we can't do that because I would just play in class and not pay attention. I do that anyway.
Dr. Wonkaberry's group meeting.
Could you imagine if we were actually in an Among Us server, like, brace yourself.
Dr. Wonkaberry.
I think she's 6 minutes.
4 minutes.
She only left like a little bit after us.
Yeah.
I feel like if I sit on this, it is going to.
If you're late for the cult stuff, you're out of the cult.
Oh!
We're not.
Just Aiden can join the cult if Alex doesn't show up.
You want to join the cult?
Yeah. Pass me a skull ring.
No, wait, no,
There she is.
We
wait.
can have spider.
There she
Alex,
is.
we're in a cult with Lorelai. You get your ring.
Rings?
Yeah.
Shit. You made it.
Aiden, because you missed your other cult.
Oh
I didn't miss that time.
Yeah.
Anyways, guys,
Oh my
you
God.
could be the minions.
This is so small.
The minions of the cult, yeah.
Yeah.
What
Oh,
are
Dr.
we
Ward, we
today?
have exciting news. We are now announcing our
Dr. Warren, your class is now home to the cult of skull rings.
Skull
And
rings,
spider rings.
Yes, yes, I
How
like
does that
that.
make you
Thank you, Lorelai.
You should be grateful I'm uniting us
I am.
under one leader.
You-
Yeah.
The workers of capitalism.
Can we get Dr. Warren a skull ring?
Oh my
Spider-
God!
Yeah,
I wish I had more. Wait.
That's, I can wait. I can wait.
He's gonna wait.
You want to join a cult?
Wait,
So
maybe you
much
have
fun.
to catch a packet of
I have 5
Oh,
daughters.
catch
Oh my gosh, wait, what if we called ourselves like the math club, but we were really a cult?
Would you sponsor us?
I probably would.
We're a cult that likes to talk about spider
We
rings
hold
and Among Us.
hands and go around a fire. Why minus
The limit as X approaches C.
It is like a spell.
I like this.
Everybody, are we meeting out by the fountain and we're gonna
Yes.
really get this thing going?
Actually,
At like 12 o'clock.
A super spreader event. So,
oh,
how
no.
did it start?
Well, Dr.
We were
Warren,
handing out rings.
Dr. Warren endorsed a cult, so.
Yeah.
They're from a COVID-free household.
That's,
Yeah,
I
because
can
we're
guarantee.
witches. Actually, because we're witches, we can like expel COVID.
Yeah, good
Like
point.
from our household.
Is
Like,
that how
we just
that
put a
works?
little like spell around.
I think so.
That's how that works.
That is 100% how that works.
Are they listening
Okay,
to
I
us?
doubt
they're joining in.
Yes, no idea.
No, no.
That
no.
sucks.
'Cause they're not
Sorry,
part of
guys.
the call. You gotta be here.
This desk is squeaky.
The desk is leaking.
Squeaky.
Squeaky.
Mhm.
Yeah, these aren't the finest educational.
You're right. You're right.
I think they look awfully 1970s.
Whoa!
Oh, I'm
Oh.
so sorry, Lorelai.
Rip. This is
And
what I
that's really
get.
shit.
That is
That's-
so depressing.
That is really depressing.
That's so depressing.
Dr. Warren, did you still have
Anyway.
Any other
It was
classes?
the cult.
This is what happens when you join cults, sure.
Are there any other classes in this room?
Yes,
Well,
I
it's
hope
their
they're, like,
fault, their
caucus.
fault.
it's their fault.
Yeah.
It's on video.
It's not on video.
Is
Shush,
that on
shush, shush.
video?
Yeah, I don't think it would have made the video.
There's no evidence.
There's no evidence.
Like, what happened? Like, nothing.
Nothing.
Nothing happened.
In fact,
These are not the droids you're looking for.
But I just saw them.
Shush, 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 shush.
This isn't leave that much of a sin.
Ooh, wow, that's like gone.
Probably a reason they chose this carpeting.
Yeah.
It's so just.
Stain
neutral.
master.
Are your shoes okay, Laura?
No. You're fine.
Okay.
I'll live. Remember the dishes. God. Oh, we have to get
that will work a lot.
Thanks.
All right, let's get our videos on. Let's get our videos on and let's stand up. Let's stand up.
I'm gonna stand over here, away from the
Yeah, you
desk.
can grab a new desk. That's good. Okay, we have what on Friday?
West.
West, okay. Which sections? 3.2, 3.3, and increasing and decreasing in 4.1. Increasing and decreasing in 4.1. Okay, let's sit back down. Let's sit back down. Math is
Proof.
math is proof. Okay. You want to know your definitions? You want to know your definitions? We've had a bunch of them so far. How many people know product rule? How many people have product rule down? Quotient rule. How many people have quotient rule? Power chain. Power chain. How many people have power chain? Okay, so we just started applying derivatives to problems where we want to find out when it's increasing and decreasing. The definition of increasing and decreasing is not, the definition of increasing and decreasing is not that the derivative is positive or negative. An application of the derivative being positive and negative is to show increasing and decreasing. But that's not the definition. And I can easily burn you on a true-false. I'm just warning you. Okay? I can easily burn you on a true-false with that. We left off, and so I want to do these two problems with you. I want to do these two problems with you because these are the kind of problems that I would expect you would have to do on Friday. These are kind of the problems you might have to do on Friday. Imagine that in both of these functions you were asked the following questions. Find the intervals of increase and decrease. So what did I say?
Find the intervals of increase and decrease.
Okay, so you're out trying to attack this, okay, and you want to find the intervals of increase and decrease. What's step one? What's step one?
Dr. Ward, can you read the application again?
Yes, the function is x to the fourth minus 4x squared plus 10. And the question is, we want to find what? Let's see if anybody remembers, see if we're in the game.
Increasing or decreasing?
Increase or decrease. We don't want to use the definition, let's use the theorem. If the derivative is positive, then the function is
Increasing.
if the derivative is negative, the function is decreasing. So guess what we want to do first of all?
Find the critical points.
Find the critical points, take the derivative. So go ahead and take the derivative. Since you're going to have to be doing this. And hopefully everybody's not too terrified.
I'm trying.
So I have a question. For how many of you am I your only in-person class? For how many of you am I like your only in-person class? Oh my gosh. Oh my gosh. Okay. Yeah. That's what I thought. Okay.
Do you know what that means though? It's like someone gets it.
That's right. Yeah. You guys take me down. No, just kidding. Okay. Okay, how many people have the derivative? How many people have the derivative? How many people think they have the derivative? So what is the derivative of this function?
Or x cubed
Minus 8x. 4x cubed minus 8x. Okay, so now that we have that, step 2, we want to create a sign chart. But in order to create a sign chart, we need to know when the derivative is 0. We want to find the critical points. So what I want you to do is take this derivative and set it equal to 0. That's the next thing. Just take the derivative and set it equal to 0. And I'll do the same thing. And I don't think that's that hard. I mean, all we did was just set it equal to 0. I want you to do nothing more than that. Just set it equal to 0. Now comes maybe the hardest part of the whole problem. Factor that equation on the left-hand side. Factor that equation on the left-hand side. Factor that equation as completely as you can on the left-hand side. And this is where the work really is in increasing and decreasing. Now imagine you were doing this on Friday. Just imagine like you're in the quest situation and you're trying to do the same thing. Does anybody have it factored? Does anybody have what they think is factored? Alex, what do you got?
4x times, in parentheses, x squared minus 2.
Okay, did anybody get that far? Okay. Okay, so now that we've factored it at least rationally as far as we can, let's try to figure out what the critical points are going to be. Let's see if you learned anything last time. How do you get to be in the critical point sorority? How do you get to be in the critical point sorority?
0.
You either make the derivative 0 or you make the derivative not a D and E. Okay, now how many people look at this? Do you see any fractions here? No, so you know you're not going to have any do not exist. The only kind of critical points you're going to have are when the derivative is 0. So we're looking for all the possible x values that could make this 0. Like look at that term, the 4x. So either 4x could be 0, that would work, or the x squared minus 2 could be 0. Wouldn't both of those work?
Yes.
Now let's look at this one. What's the only value of x that's going to make that term 0? What's the only value of x? 0. And so there's one of my critical points. Now this one's a little bit more complicated. We've got x squared minus 2 equals 0. But that would imply x squared is equal to 2. And now get ready to get kicked in the gut, because most of you will make a mistake. Now get ready to get kicked in the gut. This would imply x is equal to, and you just got kicked in the gut, okay? It's not just the square root of 2, but
Also minus.
how many times did you get burned by that in high school?
Yeah.
It's plus or minus the square root of 2. Both of those work. How many people are on the same page with me now? How many people are on the same page? Okay, now look at me, guys. You've done most of the work. You've now done most of the work. The rest of the problem is pretty simple. Create a sign chart. Create a sign chart. Just draw a number line. Draw a number line, and I'll do the same thing. Beside this number line, just put the symbol F prime. Just write F prime. Now, what were the three critical points? What were the three values that made this derivative 0?
Negative square root of 2, 0, and positive square root of 2.
Negative square root of 2, 0, and positive square root. So just make some marks on your number line for those three values. Make some marks on your number line for those three values. Just mark them anywhere. I don't care how accurately you mark them. Just mark them anywhere. So maybe I'd call this, maybe I'll call that one 0. Maybe I'll call that, and maybe I'll call this. Now you guys don't have to do this next move. This is just for Dr. Warren. I like putting zeros up there above those, because that helps me know the derivative is what there. That helps me know the derivative is 0. More importantly than it's 0 there, is that these are the, only Miles said that. More importantly than it's 0 there is these are the only zeros. Hands on the space bar, hands on the space bar, hands on the space bar, hands on the space bar. More importantly than it's 0 there is these are
The
The only zeros.
okay, that was a total fail. We totally failed. Okay, choir. More importantly than that it's 0 there is these are the
Only zeros.
And you're like, Dr. Warren, why? Because it means we only have to test one number in each of these regions to have the total sign chart. So like, give me a number that you know is bigger than the square root of 2. 2. I like 2. So let's come back here. Here's my derivative. Here's my derivative. Let's just go to the factored form. Here's my derivative. Okay? 4 times 2, positive or negative? 4 times 2, positive or negative? 2 squared minus 2, positive or negative?
Positive.
Positive times a positive?
It's a positive.
So I know everybody out here has to be positive. I know the derivative has to be positive. You know, like Dr. Warren, how do you know that? Because if it ever went negative, I'd have another, if it ever went negative, I'd have another 0, and there's no other zeros. Okay, give me a number that's way less than negative 2. Give me a number that's way less than square root of negative 2.
Negative 2.
Negative 12? Did somebody say negative 12?
I said negative 10.
Negative 10, okay, so Alex said negative 10. Are you guys willing to go with negative 10? Are you willing to go with negative 10?
Doesn't
So
matter what the numbers anyways.
So I come over here, 4 times negative 10, positive or negative?
Negative.
Negative 10 squared minus 2, positive or negative?
Positive.
A negative times a positive.
Negative.
So I know everybody's negative in there. Okay, give me a number between 0 and the square root of 2. 1. Very good, Lorelei. So now come over here. You guys help me out. Would it be positive or negative? You guys are not going to do it this one by yourself. If I chose x to be 1, would the result be positive or negative?
Positive.
Would it be positive or negative?
Negative.
This would be
Positive.
positive. 1 squared minus 2 would be negative. And you multiply those together, you're going to get a negative. Now let's say you're panicking on the quest. Let's say you're panicking on the quest, and you've at least got the sign chart this far. If you had to guess, you're not quite sure, it's not always true. It is not always true. But in a panicked moment when you're running out of time, what would you guess that might be if you just had to panic?
Positive.
And let's just see. Your guess is it's positive. Give me a number between negative square root of 2 and 0.
Negative 1.
Negative 1. So I come over here. Would that be positive or negative? I put it in there.
Negative.
Negative. Negative 1 squared minus 2.
Negative.
Negative times a negative, positive, so we have that. How many people can do that? I mean, how many people are like, Dr. Warren, I could probably do that. Okay, what was step one? What was step one? Help me out. What was step one?
Take the derivative.
Take the derivative. What was step two?
Find the critical points.
Set the derivative equal to 0. Okay, then what was step 3? Factor. Find your critical points. What was step 4?
Make a sign chart.
Make a sign chart. Now this is where it gets pretty easy. If the derivative is positive, then you're increasing. So just draw some arrows. Just draw some arrows. So in this region, would I be increasing?
It's decreasing.
So I draw down. In this region, would I be increasing or decreasing? I draw up. Here I would draw down. Here I would draw up. Now, how many people think they might get most of the credit on a quest if they just even had that? Is it pretty clear from that? But now let's actually lay it out in mathematical terms. I'm increasing, well, in between minus infinity to negative 2, I'm not. I start increasing at negative square root of 2, so if I'm thinking about increasing, I start at minus the square root of 2, I go all the way up to 0, and then I have another region where I start at the, and then I go all the way out to positive infinity. And then how do I connect these? What welder do I use in math? My union. And now you guys draw the next one. You guys give me my intervals of decrease. Okay, guys, hold them up to the grid. And you guys look off each other here without breathing on each other. Hold them up to the grid. I want to see what you guys got. Hold them up. Steve, I'm seeing nothing, man. Steve, I got nothing from you. Steve, what do you got for me? Zach, I need to see something. Yeah, Henry, I like what you have. Make the infinity one a parenthesis instead of a square bracket. Or maybe you did. I'm not sure if I'm, because you can't really hold on to infinity there. Nick, what do you got for me, man? There it comes in. Good, Nick. Good. Okay. So you guys help me out. We're decreasing on
Negative infinity.
negative infinity up. We just make this a parenthesis. It means we can't really grab negative infinity. To
Negative square root of 2.
and we almost always use closed brackets unless it causes division by 0. And then we're going to union that between 0 and the
Square root of 2.
square root of 2. How many people are kind of getting it? Okay, so now stand up, because it's going to get a lot harder. Stand up. Stretch. Zach, I guess you're not standing, but that's okay. Julia, I guess that is standing. I don't know, maybe that's okay. That's okay. All right. Okay, sit back down. Okay, now let's look at this function in the middle of the board. Read that function to the people at home.
H of x equals x squared over
X minus 1. X squared over x minus 1. Are there potential domain problems with this puppy? Is there such potential?
Yes.
Who's not allowed to play? One. It's not a JMU student.
It's
Not a
very-
JMU student.
it's
One's
very dry.
not allowed. Okay, but let's do the same thing. We were looking for intervals of increase and decrease. So let's take the derivative. So now you guys do that because this is clearly going to require a different rule than what we were requiring before. Try to take the derivative of that function. It's a lot more complicated. Mason, what rule would you use for that?
Quotient rule?
Good, very good, Mason, quotient rule. Okay, guys, wherever you're at, stop. Wherever you're at, stop. When you take the derivative of this, how many people recognize, what rule do you want to use? What rule do you want to use? How many people recognize it? How many people said, yeah, I got that, I want to use quotient rule? Okay, so you guys help me out. It'd be the derivative of x squared. And what is the derivative of x squared?
2x.
Times x minus 1. And then what's the connection sign?
One.
X squared, the derivative, the numerator times the,
Derivative of the denominator.
and what is the derivative of x minus 1? 1. All over the
Denominator squared.
denominator squared. Okay, now for the very first time in this class, like on the quest, if all I say is take the derivative, have you taken the derivative? Have you taken the derivative?
Yes.
So you don't need to simplify. You don't need to simplify. But now we're going to use the derivative, so we want to clean this up as much as possible. Do not do anything with the denominator. I'm just letting you know. Do nothing with the denominator. But let's clean up the numerator. 2x times x is 2x times x is
2x squared.
2x times 1 is.
Minus 2x.
So let's clean that up. So have 2x squared minus 2x
Minus x squared.
minus x squared
All over.
x minus 1 squared. Do nothing with the denominator. Now can you simplify that any further, guys? Can
Yes.
you simplify that any? You got 2 apples, take away an apple. 2 apples, take away an apple. How many apples you got left? 1. So this is the same thing as x squared minus 2x all over x minus 1 squared. How many people are following so far? How many people are following so far? Okay, now this is where it gets harder. We have a fraction. When can a fraction be 0? Because that's what we want to find. We want to find critical points. When can a fraction be 0? Only when the top is 0. Does this make sense?
Yes.
We never want the denominator to be,
0.
that would be bad. Does that make sense? Bad, bad, bad. Only when the top is 0. Is there a value that would blow this thing up? Is there a bad value?
Yes.
1, but 1's not in the domain. 1's not in the domain. We kicked it out. So it'd be tempting to say, hey, 1's a critical point, because it makes the derivative not exist. But since it's not in the domain, since it's not a JMU student, it can't be in the sorority. Does this make sense?
Yes.
It can't be in our critical point sorority. Miles.
So say this was a problem, right, and it doesn't say x does not equal 1, then could it possibly be a critical point?
Yes, there are cases, Miles, where maybe we wouldn't have to kick it out.
Okay.
But at this point, we'd have to kick it out. Then because it is a JMU student, it is definitely a critical point. We want that person in our sorority.
So for the x does not equal 1, was that like part of the given information, or did we get that through reference?
We just wrote it down as the domain. We just said,
Okay.
anytime you look at a function, you should ask, what's the domain?
Okay.
Okay. How many people are following so far? How many people are following so far? Okay. You're like, Dr. Warren, what do I do with the denominator? Nothing. Nothing. It's all about the numerator. What do you do with the denominator?
Nothing.
Nothing. It's all about the numerator. Okay, so now, let's look at the numerator. What is the numerator? Can you guys read that at home? Can you read it at home? What is the numerator?
X squared minus 2x.
So the only time this is going to be 0 is if the numerator is 0. So let's set this numerator equal to 0. Let's just set that numerator equal to 0. Well, when is the numerator equal to 0? Now, hey, Dr. Warren, this is a lot like what we were doing before now. What do you think the next step is? What do you guess the next step might be? Factor. Can you factor that? If you can, factor it. If you can, try factoring that at home. If you can, try factoring that at home. That's an implied sign. What does this factor into, guys? What does this factor into?
X times X minus 2.
X times X minus 2. Okay, now, what's the only values of X that's going to make this 0? What's the only value? 0 and 2. So I know these will be my critical points. X equals 0 and 2 are my critical points. They're my only zeros, so they're my only critical points. This guy's still a bad point. Do we agree or disagree?
Yes.
Okay, so now let's draw our sign chart. So draw a number line. Now instead of putting F prime beside it, you're going to put what? H prime. So let's do that. Now what are my two critical points? What are my two critical points?
0 and 2.
0 and 2, so let's go get them in the game. Here's 0. Here's 2. Now what does Dr. Warren put here and here? What does Dr. Warren put here? So I'll do that. Is there another bad point? Is there another bad point? 1. So we'll just write it here and write DNE, which means does not exist. Now let's go back to elementary school. Positive over positive. Negative over positive. Negative over negative. There's one more. Positive over negative. Negative. Okay, so that's what we're going to play. We're just going to come back here and play that game. Give me a number that's bigger than 2. Give me a number that's bigger than 2. 3. Let's come back and just look at, our derivative. 3 minus 1 squared, positive or negative? So the denominator is positive. 3 squared minus 2 times 3. Positive. Positive over positive is a positive. So everybody's positive there, or I'd have another 0. Does that make sense? Does this make sense? Is this making sense? Now you're going to be like, Dr. Warren, I hate you. Give me a number between 1 and 2. I didn't make up the problem. Give me a number between 1 and 2. Dr. Warren, there's no numbers. There's lots of numbers. 1.5. Okay. 1.5 minus 1 squared. Positive. Dr. Warren, it's squared. It's always going to be positive. Okay, I agree. Okay, now get out. If you had a calculator and you did 1.5 squared, and I'll help you, 2.25, minus 2 times 1.5, which would be 3. 2.25 minus 3. Positive or negative? Negative over a positive? Negative. So I know I'm negative in here. Give me a number between 1 and 0.
Negative 1.5.
Or just
Oh, just getting 0.5.
0.5. Okay, so now you help me out. I put a 0.5 in. It's squared, so it's still positive. I put a 0.5 here, and what would I get? 2 times 0.5? 1. 0.5 squared. Bigger than 1 or less than 1? So a number less than 1 minus 1 would be negative or positive. Negative over positive is still going to be a negative. Now you're like, Dr. Warren, you took away my calculator. You took away my calculator on the quest. now say thank you, Dr. Warren. Say it, say it, say it.
Thank you, Dr.
No, go say it at home, say it. You guys are, some of you are just like comatose right now. James, did you say thank you? Thank you, James. Okay. Steve, did you say thank you? You're like, Dr. Warren, why am I thanking you for taking away your calculator? Because that means I've got to make problems on the quest where you don't need a calculator. Where there would be some nice whole numbers and we wouldn't need fractions.
Yay.
Am I done testing regions? Am I done testing?
No.
So give me a number that's less than 0.
Negative 1.
-1, so I come over here. -1 minus 1 squared on the bottom.
Positive.
Like Dr. Warren, quotient rule is always going to be positive on the bottom. Yes, 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 yes. Now, -1 squared is what number?
Positive one.
+1 minus 2 times -1.
Plus.
Positive or negative?
Positive.
Positive over positive is a
Positive.
positive.
This is the neatest number thing I've ever made.
So now you guys help me out. What the hell were we trying to find in the beginning of this thing? What's this been all about today? Increase and decreasing. So you guys help me out. Are we going to go up or down?
Up.
Up,
Down.
down,
Down.
down,
Up.
up. This is what the graph's going to look like. It's going to go
Up.
up,
Down.
down,
Does not exist. Down.
down, does not exist,
Up.
up. So let's just do intervals of decrease. What would the intervals of decrease be? What would the intervals of decrease be? What would the intervals of decrease be? 0 to 1, we can't have 1. Then union,
Oh.
union,
1 to 2.
1 to 2, but we can't have 2. And I think you guys can get the other ones, I think you guys can. Is this making sense? Is this making sense? Is this
Yes.
making sense? You know, like Dr. Warren, this doesn't make any sense. What could a graph like this look like? What could the graph like this look like? Well, you might remember in high school, whenever you have division by 0, you put a vertical asymptote. So we know at 1, we're going to have a vertical asymptote. Okay, and then we know it will be between 1 and 0, until between negative infinity and 0, we know we'll be going up. So maybe something like this. And then we're going to shoot
All the way
down. And then we're going to go down. And over here at 2, we're going to start going back up. And so this is what the graph of something like this might look like. This is what the graph of something like this might look like. I'm not that much into graphing, just because you have graphing calculators and other things.
I was just gonna ask if you were gonna make us graph.
I'm like I said, I'm not gonna, especially on Quest, I'm not gonna be graph. How many more can do this? How many feel like they're pretty comfortable? Let's say you screw up the derivative. Are you done? Let's say you mess up that first derivative. Is the rest of the problem toast? Is the rest of the problem total toast?
Yeah.
So you want to make sure you take your derivative, thinking about it at least twice. I have toasted myself on so many problems by not being careful while taking derivatives.
Dr. Warren,
Yep.
are we gonna have any, like sheets like we did from the last quest or no? I guess A's.
Sorry, I should know something, but I'm totally lost.
Like the floor, like you let us write down our limit tools for.
Oh, no, yeah, you won't need anything. No, nothing. You're going to bring this one. You get to bring your brain. A brain and a pencil. That's what you're allowed to bring. A brain and for the rest of the semester, a brain and a
Pencil.
that's what you're allowed to bring.
One of these things is more unreliable than the other.
Mine too, Lorelai, mine too. Okay, all right, stand up at home. I can tell you need to stand up here too. Stand up, stretch. Take a look at something that tells time.
It certainly ain't that clock.
Certainly ain't that clock, no. It's
34.
I think this kind of represents 2020 right here. This represents 2020, that clock. Okay, let's sit back down.
That clock is hours now.
Yes.
Yeah.
Okay, now you guys are gonna be scribes. You don't have to be mathematicians. All you have to do is scribe. And you're scribing these two definitions. You're scribing those two definitions. Scribe. They were on the board last time, so you might be scribing the same thing that you wrote down last time, but if you didn't write it down, I'll read it for those at home. Okay, both of these are definitions. This is a definition, DEF, and this is a definition. Can you guys hear me okay? I mean, through the mask, are you guys able to hear okay? Yes. On the grid, are you guys able to hear? Okay. Yeah. Because I realize that's the sense you're using a lot because the board is so blurry. F of C is a local max. That's what's underlined. Oh, nobody's out there. I'm the only one who's just one person. F of C is a local max of F. That word is on. And what letter is that? D, and it stands for domain. It just stands for domain. So I'll read again. F of C is a local max of F on D, its domain. The next words are, I usually write this IFF, but I don't want to start new notation for you guys. If and only if. If and only if there exists I, and we think of this as being an interval, a subset of D, there exists an interval such that, do you guys remember what that word means?
Element
of. C is an element of I. C is an element of I. What word is that? And f of x is less than or equal to f of c for, and then I underlined this and capitalized it, for all x and I.
Dr. Warren, last time, instead of D, you had the closed interval from A to B. Is that the same thing?
That's the same thing, yeah. This is just a little lazier.
Okay.
Okay. So you guys read it to me. You guys read the definition of a local max. You guys read it. Your local max, f of c is a local max. F of c
is the local max of F on the domain if and only if there exists I such that C is all elements of I, and F of X is less than or equal to F of C for all X elements of I.
Okay. So that's our definition of a local max. This will not be on the quest on Friday.
Wait, what is the C, I thing there again?
That means an element of. That word is element
So
of.
it just means C is an element of the interval?
Yeah, it's just a point in the interval. That's what that means. Okay, so now look at local men. Look at local men, guys. Look at local men. Aiden, bring you back. Look at local men. Does it look like the same? If you're writing, does it look the same? Like that's one, holy cow, it's exactly the same.
Wow.
Except this is a max and that's a men. And you know, like Dr. Warren, F on D, if and only if there exists I. Now Dr. Warren, nothing's changing. Such that, same. We've got a f of x and an f of c. We've got an f of c and an f of x, and then you're like, oh, whoa. What's happened between here and here? This is f of x is less than or equal to f of c, but this is f of c is less than or equal to f of x. And again, I should probably underline the all here for all x and I. This is our definition of a local max or local min. The book uses the word relative. Miles.
In the local max, you have that such that C is the element of I, and
Do
that's
we-
not
yeah,
in local
it's
max.
not
Oh,
in
do I not have that there?
No.
You're right, I need that, thanks Miles. Thank you, sorry, my bad, my bad, my bad. In here, we need to put C's
It's
a
almost the same.
element of I, sorry, my bad, C's an element of I, thanks Miles.
Yeah.
Now you're like, Dr. Warren, I don't know what that says. How many people can read it? How many people can read it? How many people can read it? But you're like, Dr. Warren, I don't really understand it. I don't really understand it. Okay, so let me tell you a story. When I was a kid at Montgomery Elementary, did you guys go to elementary school? Did anybody here go to elementary school?
I
Just
went
wondering, did you go to elementary school? I mean,
Yeah.
I would
okay.
hope so. Made it this one.
How many people do they still do? Do you still have recess in elementary school?
Yes.
Yeah.
Did they have elementary school recess when you guys were kids?
Yes.
Did your class in elementary school, like at playground time, ever have races to see who was the fastest in the class? Did that ever take place, or was that just my generation? Where kids would actually race each other across the grass to try to determine who's the fastest?
Yeah.
Yeah.
Okay, guess who is not the fastest? Guess, you had to guess who was not. But there was a kid by the name of Chuck Treisler, okay? And Chuck was like Mercury, man. I mean, he was like Mercury. He would take off from a dead start and just be 2 yards ahead of anybody else he ever raced. And all of us thought, like, Chuck's the fastest guy on the planet. We're like, ever. And then we went to middle school, and we were doing the same thing in gym, and Larry Coombs was running against Chuck, and Larry, like, beat Chuck by, like, that much. And all the kids from Montgomery Elementary were just looking at each other. It was like seeing Achilles get shot in the heel. We're like, somebody beat Chuck Treisler? This is impossible. And then all through middle school, we thought Larry Coombs was the fastest person ever.
Then we got to high school.
Then we got to high school. And then there was a kid called Tommy Marquette. And Tommy was faster than anybody else in the school. Tommy ended up playing for Ohio State. Basketball. And we thought Tom was the greatest athlete ever. But at Ohio State, Tom wasn't even close to the fastest guy. Because I thought they had an Olympian. That's what I was trying to look up before class. They had guys that competed in the Olympic trials, sprinters, on the 4x100 relay team that competed. But I don't think any of them made the Olympics because I couldn't see in 1980. I know. How old were you in 1980?
0.
Yeah, minus 22. Okay. See, I was in college. So I'm old. My point is this: everything's relative. Say that.
Everything is relative.
Okay, so when we're talking about being a local max or local men, if you're the local max, there's some elementary school where you're the fastest. On the other end, if you're me, you could also be the local men. So there's some elementary school where you're the slowest. Did you ever play games at recess?
Yes.
Yeah.
And like where your classmates picked the teams? Did you ever have that?
Yeah.
My classmates decided to play a man down instead of choosing me. They decided to play 5-on-4. Even though I was there, they're like, Warren, it's okay. You're gonna get in the way.
That's so
And I was
sad.
like, I'm Bubble Boy. I'm like Bubble Boy. And then I went to this camp called Hidden Hollow, my mom sent me to. And they had games and I was winning for the first time in my life.
Aw.
I was getting ribbons. And then I didn't realize they sent me to a school for physically challenged people. They sent me to a camp where people were physically challenged. I wondered why the dance was kind of strange. And then this was the worst moment in my life as a human being. We were having races in the pool, and I was winning, and the kid beside me was having a seizure in the pool. And instead of stopping, I kept going to win. Instead of stopping to try to save the kid, my desire. So yeah, I don't know what that says, but it's probably nothing good.
Mamba mentality.
Then when I won, I thought everybody'd be praising me, but everybody's jumping in the pool to save. So yeah, it's like bad. Okay, but here we go. I've got.
Dr. Warren, you made me cry.
So imagine we've got a function. That looks like this. Imagine that we've got a function that looks like this. Okay, so to be a local max, there has to be some interval. There has to be some interval where you're the biggest person in the interval. For everybody else in the domain, they're less than or equal to you. You're the Chuck Treisler. Everybody else is less than you. And so I can see here, this guy, right here, this guy would be a local max. This C in the domain would be a local max. Now he's certainly not, who's the fastest sprinter in the world? Usain Bolt. He is not the Usain Bolt, but he's a local max. There's some interval around him. Now pick any other x in here. Here's x. How do I find f of x? Here's x. How do I find?
Go up and to the left.
You go up and you go over. Would it be true for every x in this interval that would always be less than or equal to f of c?
Yeah.
Yes.
So f of c is a local, this is a local
Max.
max. A relative max. In that neighborhood, he's the fastest. Are there any other local maxes?
Yes.
Yeah, I can see like, it looks like I've got one here. I'll call this D, and then I come up, this would be f of D, this would be another local max. Are there any other local maxes on the function? Are there any other local maxes? You're like, okay, maybe this guy, maybe I'll mark this as E, and there would be another local max. Each one of these people have an interval, a neighborhood. Each one of these have a neighborhood where he's the best. Now also, if you're Bubble Boy, okay, there's some neighborhood where you're the worst. And you can see, do we have some local men's here? Do we have some local men's?
Yeah.
And you're like, okay, here's going to be a local men. This guy's going to be a local man. Maybe call that, maybe not F. Let's call him nothing. I have nothing left. Ice cream cone. This would be F of ice cream cone. But there's some interval where everybody else is going to be bigger than. Everybody else is going to be bigger than that guy. Here's another local minimum. Right here. There's another local min. This guy's also a local min. This guy's also a local min. Okay, I'll just call this guy frowny face. So f of frowny face would also be a local minimum. Now who's the biggest? Who actually is the Usain Bolt on this graph? Who's the Usain Bolt? You're like, well, F of D, and then who's the biggest loser? I mean, if you're watching The Bachelor. Who's the biggest loser? F of frowny face. Is this making sense? Okay, now guys, I know you don't get this, and I guess I've got 60 seconds. it's really hard to maximize a function. If you think about profit, is that important in business applications?
Yeah.
Maximizing your
Profit.
profit. So if you have a mathematical model, and you want to maximize something, most of the time you don't want to plot it. Is that true? Do you guys like
Yeah.
plotting? Most of the time you don't want to plot it. But what I want to say is finding local maxes and local mins aren't hard if you have an increasing and decreasing chart. What did you just say, Dr. Warren? What did I just say?
Local.
Not hard to do
Not hard.
Because you notice that C is a local max, but before C you were,
Increasing.
and after C you were,
Decreasing.
and then you hit this local min and you were,
Decreasing.
and then you were,
Increasing.
and do you see how the sign chart, do you see how that sign chart for the derivative almost instantly gives you local maxes and local mins?
Yeah.
This will not be on the quest. Will increasing and decreasing be? Will increasing?
Yes.
Yes.
Okay. Study hard. Will we be in this room? Will we be in this room?
No.
No, where will we be?
Downstairs.
Basement.
Dr. Wade, can you quickly just read what the sign says for the local is? It's like F of,
Sure. F of C. Laney, F of C is less than or equal to F of X. F of C is less than or equal to F of X. And that's for all X in the interval I.
thank you.
Thank you.
Ta-da.
Thank you,
It's
Dr.
gone.
Oh, that's gone, yeah, that's awesome.
Have a good day.
Oh, thanks, Milo. Just, I'll go throw it in the dirty bag.
Are you sure?
Yeah, no, yeah, it's fine.
Where do you want me to put it?
Just put it on there and all.
Wait, where? Ashley, where'd it go?
I don't know, I asked him, I said.
Thanks.
Ashley needs to ask him a question, so.
I'm just a little live. Adding excitement and rings and
Yeah,
adding to the-
that's my job.
Yeah.
Nice.
It's probably like the house leader.
Yeah.
I know it puts all that pressure on you all the time, you know?
Wait, it's 4 to 5?
Econ.
Yes, it
Okay, so you really want me to be there for
Oh,
that?
thank God.
Wait, Alex, you said 4 to 5. You're 7